Maclaurin series. So the Taylor series, we have the formula of the series if to the raised to the n power a over n factorial times a x minus a raised to n power. Then the Maclaurin series, we have the series of f to the n raised to the n power, the quantity of 0 over the n factorial times x to the raised to n power. Example number 1, we have find a Taylor series for the function f of x is equal to ln x centered at c is equal to 1. So f prime times the quantity of x is equal to 1 over x. So x raised to negative 1 power to negative 1 x to raise to negative 2 power to negative 1, the quantity of negative 2x, negative 3 cube, to 2, the quantity of negative 3x to the negative 4 power. Then f2 times f2x is equal to negative 1 over x squared. Then f to the 3 power times the quantity of x is equal to 2 over x cubed. Then the f4 or the x is equal to negative 6 over x to the 4th power. Then f times 1 is equal to 0 and f to the raised to 1 power is the quantity of 1 is equal to 1. Then f2 is the quantity of 1 is equal to negative 1, and f3 the quantity of 1 is equal to 2, and f4 the quantity of 1 is equal to negative 6. Then f of x is equal to f of c plus f1 times c times the quantity of x minus c plus f2 the quantity of c times x minus c raised to 2 power squared over the 2 factorial plus f3 times the quantity of c times x minus c cubed over 3 factorial and so on. So f times the quantity of 1 is equal to 0 and f1 times 1 is equal to 1 and f2 times 1 is equal to negative 1, f3 times 1 is equal to 2 and f4 is equal to negative 6. So ln x is equal to 0 plus 1, the quantity of x minus 1 raised to 1 power minus 1 times the quantity of x plus x minus 1 squared over the 2 factorial plus 2 times the quantity of x minus 1 cubed over 3 times 2 times 1 minus 6 times x minus 1 raised to 4th power over 4 times 3 times 2 times 1 plus and so on. So ln x is equal to the quantity of x minus 1 over 1 minus x minus 1 squared over 2 plus x minus 1 cubed over 3 minus x minus 1 raised to 4th power over 4. So example number 2, find the Maclaurin series for the function f of x is equal to sine x. So f1 is equal to cos x, f2 is equal to negative sine x, f3 is equal to negative cos x, and f4 is sine x. So we need to substitute, we need to equate into 0. So f times 0 is equal to 0, and f1 is equal to 1, f2 is equal to 0, and f3 is equal to negative 1, f4 is equal to 0. So f of x is equal to f times the quantity of 0 plus f1 times 0 times x raised to 1 plus f2 times 0x squared over 2 factorial plus f cubed times 4x cubed over 3 factorial and so on. So f is equal to 0, f1 1, and f2 is equal to 0, f3 is equal to negative 1, and f4 is equal to 0. Sin x is equal to 0 plus 1, times the quantity of x plus 0 minus x cubed over the 3 factorial plus 0 plus 1x raised to 5 fifth power over 5 factorial plus 0 minus 1x to raise to 7 over 7 factorial plus and so on. So sin x is equal to x raised to 1 plus over 1 minus x cubed over 3 factorial plus x raised to 5 over 5 factorial minus x raised to 7 over 7 factorial and so on. That would be all. Thank you.